what I want to tell all of you here is, in this presentation, which is a sensitization for all of you to improve, to motivate all of you to carry out projects. Okay, continue with your traditional projects, but improve your civil engineering projects, whether it is project-based learning, whether it is problem-based learning, whether it is your final year project, any of these, try to introduce the concept of artificial intelligence, neural network, MATLAB. Okay, that will add value to your project. And not only that, if you're able to inculcate and learn new disruptive technologies such as this, tomorrow when you want to do higher research, higher studies, or you want to go for a very good job opportunity, all these skills will be very useful to you. With this brief introduction, on this occasion, I would like to welcome the speaker for today's presentation, Dr. Vrindha, structural engineer from Dubai, who has been kind enough to accept our invitation to address all of you. Based on her request, I'm keeping her introduction as simple as this. She was very clear and imperative that she would like to spend most of the 45 minutes that she has to deliver whatever content she has. She has been working in this area, so I'm sure her knowledge will be very useful and benevolent to one and all. So with these few words, I welcome Dr. Vrindha. Vrindha ma'am, I welcome you on behalf of my colleagues, my students, my college. Okay, welcome once again. And now I leave the platform to you to continue, madam. Over to you, Vrindha ma'am.
Yes, sir. Thank you, sir. Hello, everyone. I hope I am audible.
Yes, madam.
A very good afternoon to all. Let us consider today's presentation. Webinar has one of the important prerequisites which will help you to decide on prerequisites to learn artificial intelligence and to implement it in civil engineering projects. For civil engineers, artificial intelligence seems to be an alien word. I hope all of you will make it as your own by the end of this webinar. Today, you all will hear me for good, for better future of all of us civil engineers. So with this, I'm going to start my today's webinar on artificial intelligence and its relevance in civil engineering. Mainly, we look into address or try to address these questions. We look into what is artificial intelligence, why artificial intelligence in civil engineering, and how it can be implemented for civil engineering projects. I'm going to explain this with one of the use study of my own research work. Artificial intelligence. What is artificial intelligence? It is a technique which enables machines to mimic human behavior. It allows machines to think and act like humans, and it allows machines to perform the action without human interaction or without much of the human interaction. A technique which gives mobility and it gets updated to the real-time situations. That means usually artificial intelligence techniques will be inbuilt with knowledge updating facility. Let us understand this better with a comparison between a farmer and a drone. Here, a farmer, like he is a person like all of us, human, and the drone here, it is a machine. It is a product of artificial intelligence technique. Who is farmer? Is a person who has immense knowledge in the field. He gets assistance from other knowledgeable farmers around him or from local agriculture departments. The main activities carried out by the farmer for cultivating a plot of land is sowing seeds. He sows the seeds, he checks for the weeds and pests, and he has to decide on the pesticide for which weed. And if he has experience in all this, definitely he will go directly and he will get the pesticides to spray on his weeds and pests. Otherwise, he has to take help from other agriculture department. And he needs to decide on the manure and its use on right time. There are several other challenges faced by the farmer, like choosing right crops, right season, and predicting climatic changes. Because nowadays, this is one of the important scenario we all are facing. And the main reason for all this is us. So how a farmer will overcome all this? Because a few decades before, if monsoon, so much rain is expected, the same thing we used to expect this year also, but it is not so in present situation. Hence, he needs to have real-time access to the data, real-time series data. You need to have access. Is that possible? Yes or no? You think among yourself. And then he needs to decide on alternate crops based on the climatic condition. So these are the activities carried out by the farmer. Now let us see the drone. It is a product of artificial intelligence technique, and it is designed by acquiring complete knowledge from the field experts, from the heuristics, quantitative, qualitative knowledge across the globe, and also techniques to overcome existing and time-dependent challenges are present in the drone. That means its knowledge base, the drone knowledge base has all these components. Now, compared to the drone, a farmer knowledge, we can call it as a localized knowledge, and the drone knowledge is global and a wider knowledge. The single drone can carry out sowing seeds, inspection, selecting the pesticides, manure, spray, and then harvest. So finally, it is capable to carry out all the cultivation, like whatever required for any plot of the land. Now, let us compare these two between comparison between a farmer and the drone by answering these questions. Who carried out the work more precisely? So, whose performance is better, a farmer or the drone? And where can we expect maximum outcome after harvest? So for this, this is the only reason why we are cultivating the land. Every farmer, every one of us expect a maximum outcome from that cultivated land. So where can we expect maximum outcome? We can say the drone or the farmer, whoever is cultivating the land, if he has carried out his work very accurately, precisely based on he has considered all the climatic variations, he has chosen the right crop, and everything has happened right time, and that means with less uncertainty. So who is less uncertain, a farmer or the drone? So for all these questions, the answer is the drone. The drone, which is a product of AI technique, it stands out compared to any other single expert, not a group of experts, a single expert. You're a farmer. So he may be an expert in his field, but he will face several challenges in this world. So that can be overcome successfully by using this AI technique here, in case the drone stands out compared to a farmer. I hope you're clear with this comparison. So that comparison was mainly to give you clear idea between a human, a person, and the machine, that is a product of AI technique. So here AI technique serves better. Now products which disguises, there are several products around us like calculators, AC, washing machine, whatever. They work as per our direction. We cannot call them as a product of AI technique. So they may help us, they are helping us, but they won't work without our directions. The main example of products AI around us is iRobot Roomba. Most of us are familiar with that. So once we need to input the floor plan and the fuel, the water for this case. So after that, if we are setting the time, it will clean the entire floor and it will mop the floor by itself without any human interaction. And the second, like Alexa and Google, these are the virtual assistants, and whether we have friends, relatives, or anyone around us or not, but we have Alexa and Google, which are helping us, which are serving us better. They help us to choose the proper route, which has lesser traffic volume, and several other instances. They help us to choose right restaurants, and whether the restaurant is open or not. So every information we get from Alexa and Google, and these are the product of AI technique. Now, let us enter this civil engineering part. Why artificial intelligence in civil engineering? So here I have listed some of the important problems, challenges we civil engineers face. And you can add any number, n number of challenges are existing. So you yourself can decide. So why we need artificial intelligence in civil engineering? Let us start with this. If you are given with a project, any residence or industrial project, it has huge database. We need to handle a huge database from geotechnical, geological, hydraulic, seismic, environmental, and structural parameters. So there are several other fields also, which are subfields of civil engineering. Any person, suppose if you have an experience of 5 or 10 years in the field, can you call yourself as an expert in all these areas? All the fields which I have mentioned here, geotechnical to structural parameters. Can anyone call yourself as an expert in all the fields? No. He may be expert in geotechnical part, geological part, hydraulic or structural, whatever, but he cannot call himself as an expert with complete expertise knowledge in all the field. I'll tell you why. Here, suppose if you are given with a residence project and if you are designing this two-story building or five-story building, these 5 or 10 years, you may be much familiar with handling all these fields for these kind of projects. If something outside this, if you are given with any big apartments other than five-story buildings, any other buildings or any bridges, dams, whatever. So do you think the knowledge which you have gained by designing these residential buildings is enough to design the bridge or any other bigger projects? No, it is not possible. So that means we need a complete expertise knowledge, complete intelligent system, which is capable to handle all these parameters. And large calculations are involved, as we all know, analysis and design part. So finally, we need to compare this theoretically and software using softwares. There are diverse practices followed by all of our experts. Some are empirical, some are factual, and everything is important. Material selection and combination. It is timber, concrete, any number of products are available in this outside industry. So which one is better? So whether you need to decide upon the economy or you need to decide upon the lavishing factors. So whatever, which one is suitable for your project? And geometry. Designers and oldest requirements should match. So finally, we will decide upon the geometry. And structural functions and parametric variations. So these are some of the fields where we can use artificial intelligence. How about having a single system which does all of the above? Can you imagine any one intelligent system which gives us everything? It does analysis, it does design, it does planning, everything? No, not at all possible. So that is not, I can say 100%, like replacing civil engineers completely with robots is not at all possible. And it stands at the lower ranking, like 78 compared to other fields. It is given a number of 78. That means less likely to be replaced by robots. Now, how about a system, at least which helps us in passing some of the major milestones and some of the major problems we face during the analysis or during the design or planning? So, will that work? Yes. So I'll say yes. Such systems can be built by civil engineers. So you can become a knowledge engineer because you know the civil engineering concepts, you know the analysis, you know the design, and you take the help of other experts from all these fields. And together, if you have little programming idea, definitely we have ready skeletons available. So everywhere we have ready skeletons. No need to code everything. No need to remember the syntax. So using the ready skeletons, and once you become expert in using those skeletons, definitely you can come up with your own skeleton, which will help you to improve your intelligent system. So such systems can be built in civil engineering by a civil engineer without the help of anyone. In civil engineering field where decision needs to be taken quickly, it is always advantageous to have a system that helps engineer or advise an engineer without resorting to much of the calculations. The current practices existing in the field are time consuming and there are difficulties in measuring uncertainty. Ambiguous means the data is clear, the knowledge is unclear, and vagueness in evaluation factors and the missing information. Let us see some examples. Artificial intelligence in construction, how it can be done. Suppose, like we just will think of the issues what a project engineer will face. Project engineer has to deal with thousands of issues like quality, safety, schedule, and cost. And the thing we need to look here is there is a dependency between each of these factors. Quality is dependent on safety. And safety, again, your schedule dependent on cost. So like this, all these factors are interdependent. How can we help project engineer to deal with these issues? Which issues should he focus first? And hundreds of subcontractors, who do I talk first? How do we prevent anything which affect our project? So these are the things. So you just try to answer yourself these questions. Hundreds of subcontractors are there. If you are dealing with any bigger project, it involves he needs to handle, project engineer has to handle all these issues. So who do I talk first, and which issues the project engineer should select first? So all these are some of the problems faces, and any intelligent system can handle this successfully. Maybe the project engineer is a young engineer with lesser experience. If you are using the expertise knowledge of a project engineer who has 20-25 years of experience in this intelligence system, if you're it's like putting his brain, acquiring his knowledge and putting in the intelligent system. So that will work. That will work, and it will help the project engineers. So in this artificial intelligence in construction, we can think something related to this. And artificial intelligence in structural engineering, again, there are a number of options. Explore new structural forms. So mainly we are dealing with this. If you are just considering a frame structure, I will not enter into deeper technical knowledge in structure, because there are students. I heard students are from third sem also. So I'll give you it as a simple, like we have two columns and one beam. So you can change the structural form of this frame completely. You may use different kind of materials available, and how it is going to perform. So like this, you cannot sit and do like by doing small changes and finally you check the equilibrium and whether is that work for your project. No need to do like this. You just your knowledge will be given to the intelligence system first, like it knows how to find this equilibrium, combinatorial equilibrium and parametric variations. So it has all this knowledge. So you just by giving it structural forms, giving the skeleton of this, it is going to give us the result whether this structural combination will work or not. So something like that you can plan. And there are other dams, bridges, there are a number of structures, so nuclear power plants. So you can use your data for, use your knowledge to come out with intelligent systems. Now let us see how to build such intelligent system. I'm going to explain this with a use study of my own research work. I have taken part of my research work here, that is conceptual design of river bridge site selection system. How to select the best bridge site, river bridge site, among the proposed sites. The first and important step to carry out or to build such intelligent system is knowledge acquisition. Knowledge acquisition is the first step, as entire performance and working of this intelligent system depend upon the knowledge what we have acquired for the system, what we are acquiring for the system. So entire performance depends upon this. So special care and interest has to be taken in designing this part. Now, in the present work, assisted interviews with the experts, literature, textbooks, and quotes are the main source of knowledge base in this present work. So we have collected, we have generated computer-assisted interviews and the formats, and then we have shared with the experts, and finally computer-assisted interviews. Then with the literature, textbooks, and quote sources, we have acquired the knowledge. Organized knowledge. This is one of the important steps. After acquiring the knowledge, they may be qualitative, or heuristic, common sense knowledge. All this should be structured properly. Here we have used Fuzzy Delphi method to organize the knowledge. And finally, as we all know, to feed this knowledge to the computer will not understand our knowledge. Everything computer takes in terms of numbers, so the real numbers. So all this organized knowledge is given a weightage. We need to decide the weightage for this knowledge. From now on onwards, this knowledge, I will call it as features. So we have selected the number of features, and for each features, we need to decide the weightage. And how? We have used fuzzy analytical hierarchy process. This is one of the beautiful structure technique because it compares one factor with rest of the n minus one factors, and finally it will decide its own weightage. That means uncertainty gets reduces by doing this. That means n factor, I'll repeat, number one factor will compare its weightage, its importance with other n minus 1 factors, and finally it will decide upon its weightage. The main reason for selecting this technique is to reduce the uncertainty in the evaluation of factors. Now we have the weightages, and finally the weightages may range from maybe a fraction, decimal, or whatever. This data should be converted into a real number. It may be, it is nothing but normalizing the data. It may be from 0 to 1 or 1 to 10 or 1 to 100. So if we want in terms of percentage, or if we want in terms of fraction, based on that we need to convert. Here we have converted into a real number from 0 to 1. Using conversion scale, 7-point gradation Likert scale we have used here. Now database. To build a most practical system, we have used the data from bridge sites situated in Kerala and Karnataka. The main idea was, as we all know, any amount of theoretical description will not give us the amount of knowledge or satisfaction in gaining the amount of knowledge we expect. Hence, in order to make it more practical, we have collected the practically existing bridge site data situated in these two states. And bridge sites were selected based on their performance. Here they vary from average to more efficient. In this range, we have selected the bridge sites. And the idea of selecting this number of bridge sites completely by common sense and factual. Simply, we cannot select 100 or 200 because even our computer configuration should support us. So most of us, we are using CPU. We are not using the higher end computers for developing this. So a huge number of data, again, should not become a problem for developing such systems. And whatever the knowledge we have collected from these 15 sites should be without any void, because if we are learning from the wrong notes, the same thing, it will affect your result, because you will write wrong and finally the result will be low. So such things, to avoid such things, what we have used, we have selected this 15 number of sites which are performed in various categories from average to very efficient bridges. And finally, we have chosen this. It's completely on depending on our common sense, we can select this. Features or details of influential factors is dependent on several sources: municipality, visiting site in person. So, and we need to collect the pre-feasibility, techno-economic feasibility study, detailed engineering studies, and detailed project report, detailed design including construction drawings and assessment hours, peak time for each time, interaction with the users, and every minor input detailing is important and it is crucial. So we should not miss any important information from these sites. So we need to plan everything systematically. We need to, it's not an easy task. As it says, it's not an easy task. It requires a lot of homework. So by doing proper homework, we need to prepare and arrange this data. And we should decide, like for this site, what factors play some major role. So all these things we should consider, and finally we'll do the knowledge acquisition, data acquisition. The main problems we face in bridge engineering, or you can call it as any engineering, is uncertainty, ambiguous, vagueness, and missing information. In spite of doing a lot of putting a lot of effort in collecting the information, sometimes some of the important information we may miss out. And handling of criterias. Inexact knowledge, which is ambiguous and vague, is controlled and handled efficiently using artificial neural network in the present work. And evaluation factors is handled using fuzzy logic, and production rules has been used to design the entire user interface and then entire knowledge updating facility. So now we have, I'll just refresh you. Now, what we did at first, we have selected this important features, and finally we selected the bridge sites, and we have extracted the data. Now, the next step is to how to build the system. We need where to build the system. We need a proper platform to build it. So in the present work, we were in search of ecosystem which provides us graphical user interface builder, use standard library, simple file exchange, compatibility with standard libraries, design of whole system components, and a easy syntax. So all these features were available using MATLAB, like in MATLAB environment. So the present work for this portion, we have used MATLAB environment. Knowledge base. Now comes another important term, knowledge base. Here, the whatever the knowledge we are using, so that is present in this knowledge base. So how to develop this knowledge base? How to send this knowledge, whatever we have acquired, into the knowledge base? So we have used knowledge representation technique, artificial neural network. Artificial neural network is derived from our biological nervous system. It is nothing but a simple neuron. So I hope you all, most of you all remember this. This is a biological neuron. Here, this is a cell body, dendrites, where the cell body gets the inputs or the signals gets transferred to the cell body through this dendrites. And finally, it will transfer the information through the axon to the terminal axon and then into the connected neuron. So it is not a single neuron. Our nervous system, it is like our brain, it consists of billions of such neurons. So finally, this terminal axon will transfer the information to the next connecting dendrite of the neuron, and this is called information transfer or synapse. So coming back to this, so this is cell body, as I told, where entire processing of the information, where entire function or mapping function or transformation of the functions get developed in within the cell body. So this is compared in artificial neuron, f of x. So whatever, I will tell you what is this f of x. So this is the heart of the network, and this is called as cell body here, this portion. And this is the input layer, x1 to x1, xn is the input layer. That is nothing but this dendrites. And this terminal axon, that is y1, that is the output layer where information gets transferred to the connected layer. Here, this shows a multiple neuron. This is the input layer, this is the output layer. We can give any number of hidden layers with any number of hidden neurons between these. So my intention in taking this slide is no need to understand this artificial neural network at one shot. So this is the basic. As I told, this is just the reflection of our brain. So here, how neurons are going to transfer to the information to the connecting neuron. In a similar way, we are doing programming here. That is, information from the input layer will transfer to the hidden layer and finally to the output layer. The same thing happens here. Like cell body, information from dendrites to the terminal axon and then to the next neuron. The same way, input to the hidden layer and then to the output. Let us understand this better. So now you just forget all that. Consider two neurons. Here, this neuron transfers signal to the connecting neuron only when it crosses the threshold value. That means every neuron and every layer will be accompanied with a threshold value. For this neuron to fire the signal, the signal should cross that threshold value. Then only the information will transfer from one neuron to the next neuron. That means here you can call threshold value as one of the constraints. If a is equal to b when a is equal to c, some condition we are putting here, that is the threshold value here. And this is a simple network we have used here to generate the network for this present work for selecting the bridge site. It has input layer, it has hidden layer and the output layer. And your input layer, before sending information to the hidden layer, should be pre-processed. The data should be pre-processed or normalized between a range 0 to 1 or 1 to 10. So it is our choice. Based on the pre-processing function, like we can decide upon however we like to normalize, and we have to use the processing functions accordingly. The information from input will be transferred to the hidden layer after pre-processing. And here, entire training takes place. Entire learning of the network takes place in the hidden layer. And once the network has learned, it gives the output to the output layer, and where data will be post-processed into a user-readable form. We may expect percentage output, or we may expect the network to give in fraction or whatever. Accordingly, we can set the post-processing function, so that will give us the data which is friendly to the user. So this is the same thing which I explained here. This is a neural network. We have pre-processing function and we have post-processing function. So input layer will be pre-processed and then into the neural network where entire learning takes place, and then into the post-processing function will be applied on this output of the network, and finally we'll get the output in a form which we are expecting. So we have used mapping minimum maximum function. Supervised learning. So it is a very important concept. Here the network is trained using supervised learning. That means we have the input, we have the output. It is just like a teacher supervising the learning process of the student. That means we have the input, we have the output. Just consider input variable x. I'll explain you how it works. Here let us consider input variable x and output variable y, and using an algorithm to learn the mapping function from the input to the output. I'll just take a number now. If x is equal to 2 and y is equal to 4, what will be the mapping function? X square, isn't it? So that x square, no need to calculate using our calculations, using our partial derivatives or whatever. That part will be done by the network itself. So that means we are giving the input x as 2 and the output y as 4. So finally, that mapping function gets created within the network itself. So that happens within the hidden layer. For this case, we have taken 27 features of 15 bridge sites, and the output is this one feature of 15 bridge site. So what is this one feature? It gives us the feasibility of bridge site in percentage close to our ideal condition. This one feature is nothing but the feasibility of bridge site. Here, one input layer, we are giving this 27 by 15 inputs, and then it will be sent into the hidden layer where entire training takes place, and it gives us the output. That is one output we are expecting here. If we have 15 site data, that means 15 inputs, one column. That means it gives us a feasibility one factor, details of one factor of these 15 sites. That is feasibility of bridge site in percentage close to the ideal condition. So once it is done, the network will be trained. That means here the network information transfer from input to the hidden layer, and training takes place and gives us the output. Now this output is nothing but the predicted output. So this predicted output will be compared to the actual output we have. And finally, that difference is called as error. That error will be sent back to the hidden layer. This is called as one iteration. I repeat, the information from the input layer will be transferred to the hidden layer after training. After this network gets trained, the output, it gives us the output. That is called as predicted output. Now this predicted output will be compared to the actual output, like 15 bar 1 actual output we have. So that difference gives us the error, and that information will be transferred again into the hidden layer for further training. So many such iterations should happen before the network, we can say the network is trained completely. So once the network is trained, that network we will save in our intelligent system and we'll use it for our prediction. So that is the thing. I hope you are clear. If you are not clear also, nothing to worry. Like, so you will just understand with the coming slides. Now, how to train this network? I have just explained the entire process of training. So before training, we need to carry out some formalities like initializing the function, initializing the processing function, initializing the matrix, initializing the layer weights and input weights. So all this done using the suitable initialization function. We have used Gaussian withdraw initialization function. No need to worry about this technical terms. It is just we are initiating the network. To initiate the network, we need some requirements. So that is done using this Gaussian withdraw initialization function. Now the network function is we have used feed forward backward propagation function. That means the network will the data will be driven in the forward direction and the error will be driven in the backward direction. So finally, these things, forward movement and backward movement till this hidden layer for further training, this is called one iteration or one epoch. So many such epochs as to be, we have to carry it out one till the network is completely trained. That means the error gets minimizes, reaches the local minima to 0 or close to 0. That time the network is stopped and it will be saved in our knowledge base of the intelligence system. So the same thing here. Now this data structure net, so that network, well performed network is stored here in this net. Now we will use how to use this for our case. Now this is a network which is expert in deciding the or giving us the output whether the proposed site is feasible or not for the bridge construction. It gives us a resulting percentage close to the ideal condition. That means suppose if you say this is the network which is well performed network, then to this we will input the data, the features of this proposed bridge site. We will input the data to this network and it will give us the output feasibility of this site in percentage close to the ideal condition. So that is simple, like any user can use it. No need to have the person using this intelligence system, no need to have a strong background of the this artificial intelligence technique. So anybody can use it. You need to just input the factors of this proposed bridge site. That is nothing but the data of the proposed bridge site and it will give us the output. So this is the entire slide. I'll just refresh entire concepts. So knowledge acquisition we did, that is the first step, where we have acquired the knowledge of the bridge sites and where we have acquired the knowledge of the important features we need to consider for the selection. After that, so we have one more component here, user interface. This is the interface which allows the user to interact with the system. This is one additional component we have designed. So it allows the user to interact with the knowledge base of the system. Now inference engine uses the data of this user interface, data from the user interface, and using the knowledge present in the knowledge base. Here knowledge base, knowledge is nothing but the network, what we have saved in previous slide, as I showed in previous slide. So that is the network which is present here. That is called as the knowledge base. So user inference engine uses the data from the user interface and the knowledge present in the knowledge base and it gives us the output, which is nothing but the feasibility of this site in percentage close to the ideal condition. So this is the thing. And for every network, how can we just decide whether the network is performing well or not? So there are many performance graphs we need to compare, and there are several methods, several techniques. So here we have used mean square error graph. That means we have plotted accuracy with the epoch and the loss. Loss is nothing but the error with the epoch. Epoch is nothing but the iteration. One forward movement and the error sending backward. That is called one iteration or one epoch. So here the accuracy should increase as I shown here and the loss should go down and down. So that time we can stop our training. Now, one of the important thing we need to work on here is simply we cannot use anything, any initialization functions, there are performance functions, there are activation functions, there are summation functions involved in this network design. So all these things we cannot just take randomly and train our network. We may not achieve the performance, and also the time taken by the for training this network should not exceed certain time. That means we should happen everything faster. That to make it economical, we want this network to learn the things in a lesser time. So that's how we will work on economy. That's why we have used this fuzzy analytical hierarchy process weights as the initial weights. We replace, as I mentioned before, Gaussian withdraw initialization method is the thing what we have used to calculate the initial weights before. So what we did, in the later part, we just replace those initial weights with the initial weights calculated by FEHP. So we saw this performance convergence in shorter time. That is 1 second. If you just take it as 1 second, we have 5,000 here, the performance. So compared to this Gaian Vitro initialized weights, we have, we can see it in the graph. It has not converged yet. So even for this 1 second, where the performance is also less. So that's why we just concluded that AHP worked better. So why I explained you this is, it's just not training randomly using anything. So some like some combinations we need to try. So then only we'll get the perfect output. And also we should work, as I said, we should work on the cost. The your time factor, everything should should happen in a lesser time. Should then only we can say our work will give much better benefits. I'll just take out this demonstration showing the validation of BMSIT. I've just taken one example, like how it works for this case. Initially, we need to enter the number of proposed sites. We can investigate maximum 3 sites. And would you like to re-enter the proposed sites, because user may go wrong in typing or giving his answer. So we have help facility also to help the user. And like this, every factor data the system collects one after the other. All the features inputs of the input of the proposed sites is taken in this user interface. And finally, after collecting the data, so do you need to add any additional factor? This is where the knowledge updating comes. So if in case if you are missing any factor, so it will that option is present in the system. So finally, it gives us the proposed site is feasible by so much percentage for the construction of bridge, with some other comments, explanation facility. Thank you. I hope you're all benefited with this.
Thank you, ma'am.
Thank you, sir. Thank you.
Yeah, I do realize you're on the meeting. I believe that she has kept her word and completed the presentation on time. If any students have any doubts, kindly do address. Ma'am, on behalf of students, if I ask you a question,
Yes, sir.
artificial intelligence beyond civil engineers? Is it that it is not for us?
It's for everyone. Artificial intelligence is occupied every field, and even civil engineers need that to fill our voids. So we have experiencing, as I mentioned in the slides, we have experiencing ambiguity in the data, vagueness in the data. To address this, we need artificial intelligence. And expertise knowledge, like it is very important. I think we are losing this expertise knowledge slowly. So if some intelligent system is there to capture all this expertise knowledge, so that is again benefit for civil engineers.
Okay. Ma'am, would you say that artificial intelligence is a better way of producing results or representing results for any civil engineering work?
Yes, sir. So, I cannot give 100% to that, but artificial intelligence is one of the existing way now, like proven way, I can say, for handling these problems in civil engineering.
Okay. If a student has to take a project, maybe a mini project or a final year project, and wherein he has to integrate or utilize artificial intelligence. So, in simple words, if I say 100%, can I say that 80% of the project would be civil engineering?
Yes, sir.
And the
Yes,
remaining...
I'll answer that question, sir. Here, as I said, intelligence system is a group of expertise knowledge. So we need to work with the real-time series data. That means, suppose you are given with any problem to design a water tank design or whatever. So there are several steps in that. For each step, we can create intelligent system, and this intelligent system can be built with any civil engineering technique. So finally, we need to program that technique. That's it. So it can be built with by doing transformations or using any equations, whatever related to civil engineering, and finally that will be programmed. So that's how it works. So it can be done 100%.
Okay, thank you, ma'am. Now, students, if you got any doubts, please raise it. If you got any questions to ask, madam, you can please raise it. Ma'am, you can just
Yes,
for
sir.
last one more question from my end. So you spoke about how you have used artificial intelligence with respect to your doctoral research, right?
Yes,
So
sir.
uh, can I understand that, whatever discipline of civil engineering it is, it could be a public health engineering or soil mechanics or structural engineering or water resources or,
Yes, sir.
geology, any sub-discipline of civil engineering, can we use artificial intelligence?
Yes, sir. Anybody can use. Anybody can use.
So,
Only like for developing our civil engineering machines, we need a knowledge engineer. Nothing but we are the knowledge engineers who are civil. So civil engineering experts are the knowledge engineers. Along with that, we need some programming language so that can be learned because we have a skeletons, ready skeletons. Nothing to learn or memorize. Nothing such things are there. So that is 90% is civil, and finally some percent, 10%, like we need to learn these techniques to implement in AI.
So, will I be correct if I say that if the students or any civil engineer, if that boy or girl has knowledge of artificial intelligence, would that the quality of whatever they do would be enhanced, and would that help them with respect to the career or research opportunities or higher studies? Would that?
Definitely, sir. Now, yeah, everywhere they're asking for, because I am here. Like when I go for any such like talks or interviews, I often I'm very much delighted to see that civil engineering, like it is very fast moving here using artificial intelligence, and everywhere they're asking for AI knowledge, simple machine learning language, their knowledge of this ML, they're asking everywhere. And definitely to take civil engineering to the top, so we need this AI, we need to learn this AI. So any course which will help students to learn AI machine learning, so that will help benefit them a lot for their future.
Okay, that was my next question, ma'am. Can you please give few glimpses of, or can you please tell my students how can they go about learning the basics, just the simple fundamentals? Is it a massive open online course? I'm just trying to motivate
Yes, yes,
them
yes.
to
There
tell
are
them.
several, yes, sir. There are several online courses now existing. Like before going any taking such courses, I suggest them to learn the basics of artificial intelligence themselves in the Google. I say no need to refer go for any textbook. You just learn the basics of artificial intelligence. Now I'll say I'll just put on two technical words: machine learning and deep learning. These are the existing things. Now machine learning has been replaced by deep learning because of its capacity to do any work, anything in lesser time. So only now let them learn about this artificial intelligence. Let them Google it, and finally they will come to know what is machine learning, and then to the deep learning. These are interconnected things. So deep learning is inside the machine learning, and ML and DL are inside the artificial intelligence. So let them start with the basics of artificial intelligence. Then how to use this concept in machine learning and deep learning, that they will learn it gradually. So once they are very much familiar with these concepts, they can take up any courses.
Okay, perfect. Thanks a lot, ma'am.
Thank you, sir.
Yeah. Now, students, do you have any questions that you would like to ask, madam? Any questions from anyone? Unless otherwise, I have asked a question on your behalf.
Just a minute, sir. Sir, sorry to interrupt.
Yes, sir.
Yes, sir.
Hello, sir. It's a very excellent presentation, madam. It is very good.
Thank you,
It's
sir.
very informative.
Thank you.
I have one clarification regarding that huge data management. So data management and machine
Yes,
learning,
sir.
data mining, all these things are comes under in the AIL, AML, artificial intelligence and machine learning.
Yes, sir. Yes, yes. That is data science is again, it comes under artificial intelligence. Data
Yes.
science is again a bigger subject because
Okay.
we are available like many pre-trained layers. Pre-trained layers are available in the network. It is an open source for us.
Okay.
That is done by this data scientist. So
Data.
that means we should have this to collect this data itself is a technique. That is not just simple. Anybody cannot go and collect this data. So
Okay.
collecting data it involves several other techniques. So that can be done using this data scientist. And since we are the knowledge engineers, it is not
Correct.
it is easy for us to use do it
Yes.
in civil.
Are the GIS, Geographical Information System, as it
Yes, sir.
supporting this data mining or the machine learning software? Might have
Yes, mainly, yeah, that is work with CNN
Python.
model.
Yes,
Yeah, Python, CNN,
Python.
convolutional neural network.
Yes,
Yes, and
yes.
other advanced networks are also available nowadays because it is
Okay.
very everything is getting replaced very fast. So
Okay.
because so many are into this and so many are they are claiming the patent for different layers and they are useful also. Like
Yeah.
it works with the CNN images, everything, different images and all we have to and that is possible. And there are several works in civil also.
Okay.
There
Okay.
papers are
Thank you, madam. Thank you.
Thank you, ma'am. Thanks a lot. Are there any other queries? Any questions from students? Any other questions? Okay, if there are no more queries, then I would respect the time that madam has provided us, and I would also like to respect her time now. She has to get to the next meeting. So, Vrindha ma'am, I would like, on behalf of my college, my principal, my management, my colleagues, my students, on behalf of everybody, I would like to extend my thanks and gratitude to you for sharing your valuable time and your precious knowledge. I'm sure that this could have been an eye opener for many of my students who actually feel that artificial intelligence is beyond us. So I thank you, and probably I expect I would request whenever you're free in the future, several months down the line, probably we can get together again for some other interactions, at one step higher. Now that you're given an introduction to us, maybe we'll go one step higher, and probably if there's any opportunities for us to collaborate on any engineering project, probably we can have you as an external guide also. Based on your convenience, of course, we can look into that. Okay, so now.
so sure, I'd be more than happy to help like students, and I want students to learn because I don't know how much they have understood with this presentation, but I thought it would be a prerequisite for them. So now they know some technical terms and how they can just go with this. So just whether you are interested or not, just browse it AI and other related terms, just try to get the knowledge because it is slowly everything is changing nowadays and for your future for all of us, so something we should do it very strongly at this time. So I request all of you to do this, and thank you sir, thanks for giving me this opportunity, and
Thank you.
yeah, thank you sir.
Thank you, madam. And is it still good morning for you there?
It is going to be afternoon after 40 minutes, sir.
Okay, all right. Thank you. On behalf of Department of Civil Engineering, I'd like to thank Dr. Vrindha once again for this international webinar. Thank you, madam. Wish you
Thank
a
you
safe.
sir.
Take care. God bless you all. Thank you.
Thank
Good
you
day.
sir, take care, see you. Thank you sir.